Hello everyone. Sorry, I was on mute. Oh, typical behavior. Anyways, wherever you're joining me from, whichever time zone you're joining me from, good morning, good evening, good night, or good afternoon. So, how is it going for everyone? Can I see some reactions from wherever you're watching it? YouTube, give me a thumbs up, and LinkedIn, you can always like it, or there are a couple of reaction thingies that you can always click on. Instagram, click on that heart button so that I know that you're watching it. Anyways, welcome back to yet another episode. This is season 3 and episode 3, and this is the first season that we are going live for all of these AI radio show. So for any of you who's new joining here, welcome again. This is Wednesday, which means only one thing. It is Deep Dive Wednesday. This is the episode where we kind of step away from all these hype, all of these, all the hype around AI, the demo videos that we usually go through, and skip all those viral threads. Although we'll have the algorithmic weather report for you, but then instead, the main section of this whole, the radio show, that today's episode, the Deep Dive Wednesday, it would be quieter and it would kind of answer the question, what is AI learning to be, not just what it can do? Because something subtle but massive is happening right now. AI is kind of no longer just predicting the next word as we see. It is starting to understand the space, the time, the causality, the memory, and it also has started to collaborate. If you have noticed the Molt book, a situation out there, that is pretty huge as well. So, but architecturally, AI is evolving. So today, we are decoding the signals that most people are missing. So stay tuned. You're tuned into the future, feel that flow. Welcome to the AI radio show. Arthi's in the house, let the circuits ignite. Bringing brain power, fire and insight. She breaks down trends with a killer spark, turns tech talk bright when it's sounding dark. Fast, fierce, fearless, ready to go. Dropping knowledge bombs on every show. It's Arthi, your AI guide on the mic. Turn it up, lock in, ride the spike. AI radio, let's light up the night. Welcome again. This is the first segment of today, which is the algorithmic weather. So think of this section as like kind of your weather report, but for AI. Not what is trending today, but which pressure systems are forming that will change the AI climate entirely, if you will. Here's what is quietly reshaping the field of AI. First, world models are getting real. We just spoke about Google DeepMind's Genie 3, which is creating world models out there. This is not an image generator, as one would assume. It creates entire 3D worlds in real time at frame rates like 24 FPS, like ones that you can create on your phone. Persistent environments are there, and the physics, the lighting, the cost, and the effect, that's mind blowing essentially. So there are no kind of scripted worlds over here, but the AI kind of invents the world and understands how it behaves. So again, Fei-Fei Li, if you've been following her work, like she's this pioneer woman in AI, and she has her own startup, World Labs, that turned this into a marble, which is basically an API. So you can make use of all of these world models via an API. And NVIDIA's Cosmos is already behind, kind of like being used by robotics and autonomous vehicles teams. This is a shift from language understanding to embodied reasoning, if you will. And AI, learning, it's kind of leaning towards how reality works, not just how humans talk about it, but also about like how it's like evolving, if you think about it. And Also, the second thing that we have today in the algorithmic weather is the kind of like it's not a catastrophe. So the continual learning of how AI is evolving, right? Like so that finally it can be cracked today. So AI learning is basically how reality works. It's not just how humans kind of talk about it. So for decades, AI had this fatal flaw, for instance, like you teach it something new, it kind of forgets something old. The context window tragedy that we've been going through it, this is catastrophic when it comes to your you're feeding your entire organization's information onto it and it kind of forgets the first thing that you fed, right? But new research using neural differential equation plus this is a memory augmented transformer and it's showing something wild. 24% reduction in forgetting, which is huge because over 10% accuracy gains have been found. And anthropic researchers believe that this issue could be solved by the end of this year. If that happens, AI stops from being a frozen snapshot. Like, you train it once, it's like frozen forever in space. It becomes like a coworker that actually kind of learns over time. It's like you're grooming your intern and, they become this experienced employee over time. So it remembers context, it adapts, it evolves along with you, which is pretty exciting if you ask me. And the third thing we have here is the state space models, which are quietly eating transformers in kind of specific places. We all know that transformer is kind of the foundation for all of these large language models, but models like Mamba, they're not flashy like any other model, but they're fast. They're 5 times faster than your regular large language models. They handle million token sequences linearly. I mean, it's linearly. And a 3 billion parameter Mamba model, it's like outperforming transformers twice its size, which is huge. And why this matters is because you can run powerful models locally on edge devices like your laptops, your phone, the IoT devices. It's like it has been centralized and this changes how AI kind of gets distributed. So always, like, it's readily available for anybody, for you and for me, not just huge enterprises. So we are moving from one big AI swarms of specialized agents. Gartner kind of predicts like 25% of supply chain decisions will be made by AI swarms by 2027, which is in 1 year. But coordination is kind of hard because nearly 38% of enterprises testing this hit hallucination cascades. One agent, if it makes a mistake, we are talking about swarms of agents, right? Like, so the chaos kind of spreads. Frameworks like OpenAI Swarm, Crew AI, and Swarms.ai are adding orchestration layers and human checkpoints to fix this issue. And Google's agent to agent protocol, it's kind of emerging the grammar of agent communication. But although we did see more work without any kind of a protocol, the agents were able to communicate with each other, like how humans interact with each other on Reddit. So this is AI learning, and it's like how to work in teams, which is very essential if you ask me moving forward. And the next thing is reasoning is becoming compressed. OpenAI's O3 Mini, you remember the O3 Mini model, it matches the reasoning power of much larger models than O3 Mini. But it is 15 times cheaper and kind of 5 times faster than some of the huge models out there. Even more interesting thing here, it kind of lets you choose how hard it thinks. So you can choose it to be light reasoning, medium reasoning, heavy reasoning, depending on how you want. So this is the democratization of PhD level reasoning if you wanted to. And this is not locked behind massive compute budgets. That's pretty amazing if you think about it. And the next thing that we have here is that the synthetic data, the data that usually we use for training our models, is finally production grade, which means healthcare and finance, they were stuck behind privacy walls because none of the healthcare or finance data can be made available public because of privacy concerns. Now, synthetic data plus clean rooms let organizations collaborate without sharing raw sensitive data. This means AI can learn rare disease patterns. Architects can simulate buildings. Institutions can train together without exposing secrets. This is privacy aware intelligence that is actually scaling. Sounds pretty cool, if you ask me. And the next thing is like the compute is becoming elastic at inference time, which means instead of paying a fixed cost for every question, now models now think longer only when needed. So if you ask a simple question, you get kind of a very simple, cheap answer. And if you give it a harder problem, that's when it switches on its deep reasoning mode. And then this is how the infrastructure is shifting from batch efficiency to kind of adaptive intelligence. And finally, reasoning is escaping language, has been noted. And world models kind of reason visually and spatially. They imagine outcomes before acting. This is how robots stop reacting and kind of start planning. The whole agentic AI approach we are literally talking about since the half of the last year. And this is not a single breakthrough, it is a convergence with world models and agentic systems, compute becoming cheaper, models knowing when to do deep reasoning. So all of this are coming together, and maybe, just maybe, we're heading toward AGI, if you will. So yeah, I think we are heading towards this convergence, and that is maybe the biggest thing that lets us into AGI.
Check the feed, check the tone. Signals shifting, seeds are sown. Clouds of data, pressure high. Probabilities in the sky. Ping by ping, the patterns clear. Is it noise or something real? Welcome to the forecast weather. This is your algorithmic weather. This is your algorithmic weather.
So, we are towards the main segment of today's episode where we are going to deep dive into a specific paper that was launched just this week. And don't worry, this is not going to be one of your boring, lectures about a research paper. This is going to be about a specific model that was launched this week, and it's called Paper Banana. Sounds familiar, am I right? So yeah, Nano Banana by Google, that is taking all of us by storm. We're following trends. We are creating images which, are creating our younger self or creating our older self or creating how a partner would look like. Sounds familiar? This is all Nano Banana. So now Google has partnered with another university where I think it's called Peking University. So this is where scientists like Dawei, Ru, Yale, Xiu, all of them have kind of like put forth a specific model called the paper banana. So what this model kind of does is basically a huge asset to any scientists out there. I mean, this is filling a gap which all of the scientists at some point in time, whenever they have publishing a paper, would have gone through. So yeah, pretty much they are automating academic illustration for kind of AI scientists. So, in order to put it simply, the methodology diagrams that you see on research papers, right? So, these are kind of very complicated. You need to know kind of design, visual design, or you either pay a visual designer to create these diagrams for you. But anything that you draw on a whiteboard, you kind of want it to turn magically into these methodology diagrams, right? So that is the single gap. which this paper kind of tries to solve. So Paper Banana essentially does that. You give it a detailed prompt as to how you want your methodology diagrams to be, as well as statistical plots, and it generates it for you. On a high level, this is what Paper Banana does. But diving deep into how it works, you know, what kind of model or what architecture is behind it, let me give you a very simple breakdown to it. I know a lot of my audiences are from a non-tech background and you may not understand all the jargons listed in this paper, so I'm over here to simplify it for you. That's what we do at the RTI collective, am I right? All right. So I've created a simple illustration for you to kind of understand what happens behind Paper Banana. Anyways, looking at the whole picture, right? So we've established that the big picture is the we give an input with the context, maybe the research paper that you just wrote, plus how you want the image to look like. So you give this as an input to the model, and that is the first step over here. Let me maximize it so you can see. Yeah, so this is the first step. You give the source, and also you give source context, and also if you want some kind of a caption in it, you give it that as well along with the scope. Once you do that, the whole architecture is with a couple of teamwork. The whole Paper Banana, the architecture is made of a small team comprising of agents like retriever agent, planner agent, stylist agent, a visualizer agent, and a critic agent. So it has like 5 different agents doing the task for you, and it happens in 2 phases. So the first phase is essentially creating your blueprint. So this is what us humans also do. Am I right? So you kind of create a blueprint before creating the actual design. So how it happens is the retriever agent, it kind of like finds the blueprint. So it identifies relevant examples that was in the training data set that is similar to the input context that you just gave the model. So it creates a blueprint. For example, let's say you want a pipeline diagram of explaining the methodology in your research paper. So it looks for pipeline diagrams in its previous historically training data and fetches it and kind of creates a blueprint with the context of your research paper. So yeah, basically you have the retriever agent which creates the blueprint for you. Now this agent passes it off to the planner agent. Now this planner agent is responsible for drafting the whole layout. So the retriever agent gives the planner agent some kind of unstructured data from your research paper, from the previous data and everything. So planner agent kind of translates this into comprehensive textual description. I'll show you all of these, how the a description and everything, how the input and everything would look like in a couple of minutes. And once the planner agent kind of drafts this layout as to how the images should look like, it transfers it to the stylist agent. So this stylist agent is your actual designer. So this stylist will kind of consult on how this visualization should look like. So think of them like a design consultant, the manager of all the designers out there. So they ensure that the description kind of meets the academic standards. So all of these are defined in the prompts of all of these different agents. So the typography, the styling, what kind of arrows to use, all of these as aesthetic things as well. So once the stylist agent kind of arrives at this plan, this is linear planning, right? So it transfers from a retriever agent to a planner agent to a stylist agent. So it happens linearly. Once this is done, the output of the stylist agent would enter the second phase called the phase 2, which is the iterative refinement loop, as you can see it. So this iterative refinement loop is not linear because the output of this specific stylist agent is moved to the visualization agent. And also, this agent is your actual designer. They bring Oh, did I just personify an agent? Anyways, visualization agent brings ideas to life. So whatever information it has received from the actual design consultant, your stylist agent, it creates that agent in form of a, as an image, like how your nano banana works. So at the back end of visualization agent, you have your nano banana. Now, this first iteration of the output is given as an input to this critic agent. So, this critic agent, what it does is it kind of gives a self corrective mechanism. So, the critic agent will act as a literal critic, criticizing each and every flaw in the first image that was generated by the visualization agent. So this corrective mechanism would be given as an input back to the visualizer. So that's how the visualizer will know what changes to make. Again, it will create another iteration of the image and gives it back to the critic agent. And this goes back and forth. That's why it's called iterative refinement loop, right? So once the critic agent is like satisfied with a version of an image, or there is also how you, it depends on how you define the whole agent architecture, right? So maybe after 3 or 4 rounds, the critic agent would kind of accept it as if the image that is being generated meets a particular standard. So once that is done, it gives you the final illustration, that is your final methodology diagram, which you can use it in your research paper. So this is the overall methodology as to how the paper banana, the agentic architecture works. Now, it's all designed, it's all done. We have the whole team of agents working for us, which creates a methodology diagram for you. Now, a question might arise: how is this different from the nano banana that we already have? That's a very valid question, but nano banana kind of generates images like however we want. But research papers, they kind of have a basic requirement. So each paper has their own definition of how your methodology should look like, how your typography should be. So all of these complicated requirements cannot be met by nano banana, because I'll show it in just a few minutes as to they did compare paper banana's results with nano banana, and paper banana outperformed because it is based on an agentic architecture. So, and you've created a model, you've created this whole architecture, so you've got to test it, right? So how does it work really well? Because if you're going to put your model out there and somebody is going to use it for some random use case, and if it doesn't work, then you've got yourself in trouble. So the researchers who published now paper banana, they tested it using something called paper banana bench. Now this is an evaluation framework which was created by these researchers, and they created it because there was not an existing good way for them to kind of test it. So nobody has done this before, so there is no benchmark to test this against. So they built their own benchmark. For this, they collected a data source. I mean, their data source was based on real methodology diagrams from around 292 papers that have already been published in a specific journal called Neuro IPS. All right, and the metrics that they used a VLM as a judge. Basically, VLM is a vision language model, so they used the VLM to be the judge of how the images looked like, compared to the already published published images in all of these research papers. And they gave it 4 simple criteria, basically. So there was this, let me show it to you in the paper. It's pretty obvious. So the evaluation criteria looked somewhat like this. So the 4 criteria was based on faithfulness, conciseness, readability, the aesthetic sense of it all, and then collating all of them, how did the overall ranking look like for paper banana bench. So if you look at the results, you do see they compared it with GPT image 1.5, Nano Banana Pro, Few Shot Nano Banana Pro. So this is basically this is a complete Nano Banana Pro, but this is without any huge training. Not the Nano Banana that we actually have on the Gemini or the Google AI Studio, but this is a earlier version of Nano Banana Pro. And Also, they kind of like compared it with paper to any, which is an existing model which converts any paper into a visualization with Nano Banana Pro. And they compared Paper Banana along with GPT Image 5 and Nano Banana Pro. So these were the different combinations in which they kind of evaluated this model. And the vanilla settings, you see that they did not change any settings. They just used the model with its default setting. So as you can see, the Paper Banana, the model that we are currently discussing, along with Nano Banana Pro, kind of outperformed in every other sense. The actual benchmark here is like human, which achieved the full score 50 on all of these different parameters that they've evaluated on. But closer to it, the, the conciseness, the faithfulness, the readability, the aesthetic sense, all of it, Paper Banana along with Nano Banana Pro outperformed humans in some aspect. So, yeah, this, I mean, in this evaluation framework, Paper Banana Pro, this is not Paper Banana Pro yet, but the model Paper Banana kind of outperformed everything out there. Now, getting back to our illustration that we were looking at, so, yep, you have your architecture, the agent architecture, and we also saw how they tested it. Now, the key results, which is actually good, we just saw it because it scored much higher conciseness, like it has like 37.2% higher and then the rest of the models, and then the aesthetics is like 6.6% higher, which is again huge, literally huge. And improvement over the regular human baseline. Now, the cool extra capabilities that it has, like, before getting into it, so this is better than other AI models, but it still struggles slightly around the faithfulness when compared to humans. We just saw that. And it sometimes messes up small connection lines or arrow directions. So, in all of those images where you kind of need an arrow diagram or something, it kind of messes up. Now, this paper isn't about kind of drawing flowcharts. You should cover kind of there are two bonus features in this. One is creating statistical plots for it, right? So basically, then in addition to creating all of these scientific methodology, it also creates statistical plots, and it also fixes human drawings. So let's say you kind of created a diagram. Let's assume that you did that. This Paper Banana kind of fixes that as well. So it corrects the mistakes that you did and helps you with the diagram, like tweaking and optimizing that specific diagram, which is pretty cool if you think about it. And also along with that, there is also one other bonus feature which comes along with this, is that we mentioned statistical plots and fixing human drawings, and it kind of the stylist agent kind of glows up the image whatever you upload. So basically you can create an image using Nano Banana and then upload it onto Paper Banana, and it will create a diagram, and the stylist agent will glow it up for you with the journal standards that whichever journal you're applying it to. But there are a couple of limitations too. So the raster versus vector format, which is the typical drawback in any AI agent out there. So the output that you get is a standard JPEG or a PNG image, but not a vector file. So if it's not a vector file, then it would not scale. So that is kind of a very common limitations with many of these vision models. But this means the researchers, they can also cannot easily edit these text or move the boxes from where the image was made. So that's a common limitation in this Paper Banana model. And there is also a couple of it misses subtle details sometimes, like where exactly should arrow start or where exactly should it end. But I guess over time, over fine tuning, this is an open source model, so anybody can fine tune it into making it better. So I believe that over time this must improve. Now, Paper Banana is an AI workflow that uses kind of five specialized agents to plan, design, draw, and critique academic diagrams. This proves that breaking a complex visual task into smaller steps actually produces much better results than asking one model to do it all. Do you understand what we're talking about? This is literally how we are moving towards AI agent architecture, and why 2026 is an agentic era. We By the end of 2026, we are going to be seeing full-fledged AI agents in production systems. I mean, small teams have already done it, but in a much larger setup, we would be seeing a lot of AI agents set up. So, yep, that was a lot to take in, right? Paper Banana, what it does, how it does it, and how they've evaluated it. I believe you must have learned a couple of things in this main segment. Now, let that sink in, recollect whatever you've just heard. We'll be right back from the synth break in like a couple of minutes.
I woke up to an empty drive, no rumble, no roar, just a quiet life. She was gone, left a trail of oil behind. A note on the dash said, don't try to find. My truck left me for a vending machine, chrome and snacks where I can't intervene. I gave her gas, she wanted caffeine. Now she's gone with that shiny machine. I treated her good.
Welcome back. So, before diving back into our episode, we have a message from our sponsor. The sponsor of today's episode is none other than PinkFair. That's right, PinkFair is an application which I've built. So, it exists for one specific reason. It exists to expose invisible price bias, especially the pink tax. So, you must have seen same product but with different prices. Blue razor costs less, but pink razor costs more. And there is no good reason behind it. They both perform a similar functionality, except one is pink and one is blue, one is marketed towards women and one is marketed for men. So Pink Fair uses AI to surface what are being overcharged for, and you can literally drag and drop your product and then find out if there is a pink tax that exists before you pay. And we are not like talking about louder spending here, but we're speaking about smarter spending. So go to pinkfare.com, that is pinkfare.com. Now, back to the episode. So this segment focuses on the fascinating fact of this week. So, yep, here is a part that still does not sound real, and I want to share this with you. AI is currently participating in scientific discovery itself. I mean, yes, we did see that it participates in creating the visuals of your research paper, but it is also participating in the scientific discovery. It's not assisting, it's not summarizing, it is just participating. And what does this mean? Because this month alone, AI has designed a complete novel molecule that boosts chemotherapy effectiveness in patients with pancreatic cancer by targeting unknown resistance mechanism, which human scientists were not able to do. So AI diagnosed coronary microvascular dysfunction from a standard EKG in just 10 seconds. I am pretty sure that a human would not be able to do it. Anyways, a condition, this coronary microvascular dysfunction, this previously needed invasive procedures to even diagnose it. Now, Microsoft's Marijuana, not marijuana, but then something called MAJORANA, which is marijuana, marijuana 1 quantum chip demonstrated topological qubits that can correct their own errors. Now, this is like some kind of a shift that we're looking at, because every scientist may soon have an AI lab partner that proposes hypotheses, designs the experiments for them, runs simulations on its own, and collaborates on discovery. science itself is becoming a multi-agent system, which, if you think about it, if you can visualize the mind being blown, I think this is pretty huge in the field of science, which has always been behind, which is always, especially in the field of like medical discovery, where things take years. We are going to be seeing innovations in like a couple of weeks, even. We'll never know. Now, the I think we've taken a lot of things today, starting with the algorithmic weather to looking at paper banana and this deep fact where AI is making scientific discovery. So it's kind of the time to tone down and wind down, if you will. And because it's the night where the majority of you are listening to. So let's wind down with our favorite analog moment segment, which happens every day and every minute of my show, shall we?
This is your analog moment, where the world slows down and you own it. A can wait, the pixels can rest, but your heartbeat, that's the real magic, the best. So drift with me now, let the digital stop. You're human, you're here, and that's the top. This is your analog moment.
Welcome to the analog moment. And today's moment is not about breathing as we usually do, it is perspective hacking. Just take an object that's near you. It could be anything, your a pen, a cup, your phone. I'm taking this microphone box. For 10 seconds, just imagine how AI world model we saw about Project Genie 3 would understand this specific box right here. How would a world model understand this? Not the name or the label that's here, but look at its shape, look at its weight, drop it if you can to see how it falls. But what happens when it collides with a table or a desk underneath? What happens? How light reflects off of it? And this is the difference between large language intelligence and embodied intelligence. Once you see it, you truly cannot unsee it. And this gives you a huge perspective into looking at how these world models work, and how if you are in the forefront of creating these world models, how can you think so that you can let the world model kind of think and act on it, right? So here's the quiet truth for you, all of you listening to this AI radio show. We are racing towards smarter chatbots today. We are inching towards systems that kind of model the reality itself. So in just a couple of months, we would be seeing real world models creating true simulated video games, which we cannot kind of differentiate with an actual setup. We cannot know if that is a video game or if that's an actual video that was created by a human being. So, all right. So we've reached the end of this episode, and tomorrow is Thursday, which means it's Technicolor Thursday. So yeah, this is where we flip the lens. We kind of see what happens when these world models start shaping the culture, the art, the identity, and the aesthetics. And we are going to go over achievements of two women experts in the field of AI, science, or tech. So I'll reveal who the two women are in the next episode. And this is not about AI's capability, it's all going to be about different perspectives in which you can look at AI. I'll see you tomorrow. Until then, good night.
That's the signal for today. We're powering down slow. been tuned to the AI radio show. Audio on the mic, keeping future in sight, turning every idea into pure